yes, I do want to try to give you more time to work on your masteries because I know there are about 5 of you that are not finished, like officially, and then there's another probably 7 or 8 of you that my grade for you right now is fix this. So if you fix it, it's a mastery. If you don't, it's a progressing. Right now, it's kind of in purgatory. If you don't know what that is, it is that spot after you die where you get stuck trying to prove whether you're good or bad. So I would love for that to happen today during class, and you can give it right back to me, and I can change your grades real soon, and the world's wonderful, and birds sing, and the sun shines. Hey, you don't need that yet. Does the screen say get a yellow sheet? No. So if this doesn't say to get today's sheet, that's probably on purpose. Like, I know that some of you, because I come around and I tell you to stop doing this, start your homework while we're doing class together, and you start ignoring what we're doing together. That's a bad decision, because what we do in class informs your practice work, and that informs your mastery work. If you miss something we do in class, that could very easily come back around on a mastery. So we're not checking any previous practice today because we're trying to get through the lesson quickly. So you're just going to get a sheet of graph paper out in the resource page from last week that has all these crazy tables on the front of it and one big graph on the back about the redwood tree that John is trying to grow and is tracking data on, which I am that weirdo that would track data as my trees grow. I had to put fences around the new trees that I planted because my dogs wouldn't stop peeing on them. Yeah, I know. It's actually a sad story. You laugh, but it's a sad story. So, I want to see how good we're doing at this yet. And what I mean doing at this is figuring out the pattern and being able to fill in these tables. So like what you saw on our practice last week, and you'll continue to see today and on more practices in the future, we're going to play a game that literally has the word silent in it. So what this means is you don't need to talk. Your teacher, hey, that's me, will put an XY table up on the board. You will study, yes, that is not me, study the input and output values and look for a pattern. Then, none of this takes talking. Write the rule in words and symbols that finds each Y value from its X value. So you want to be able to write out Y equals some rule or some math that has been done to the X. Okay, you want to be able to say Y is, like if Y is triple your X, it'd be Y equals 3X. Right? Or it might be Y equals 3X plus 2. Or Y equals X squared plus 2. Or, you know, things like that, like we saw with the tile pattern. But now we're not going to have tiles. We're just going to look at the numbers. This is on your graph paper. So that's why you need the regular out. This is on your graph paper. That is why you needed that out. So nobody needs to talk because, seriously, I don't want you to give it away. It's hard for you to realize this, but in the math classroom or in any classroom where people are learning, you shouting out the answer is like robbing somebody else of their opportunity to think and make that jump on their own. So imagine if you had never been able to feel that like joy, and it's seriously just joy, like it makes you happy when you figure out a problem. Right? When you're like, oh, I got it. Don't rob somebody else of that. So write it down. Okay, do not shout it out. Write it down. Logan?
I just wanted to ask, is it possible, so let's just say you drew some sort of like weird line on a graph.
Yeah.
Is it possible for like every sort of random thing you put on a graph for there to be an exact function that would exactly match?
At an exact moment? Sure, but not continuously. Yeah, you could put stuff on a graph that is so chaotic that you couldn't give it one behavior, but in a tiny little like part of the graph, you could describe that momentary behavior. But when you expand out, it wouldn't work.
It's actually impossible.
That's a big claim, so I don't know. I'd have to research it more. So, again, is your question on topic? We're not making graphs, we're looking at tables right now. Your question is off topic. So I can't answer that directly because that's not what we're talking about. But the general answer, the things we talk about in class will have definable behavior. If you want to go out in left field and do something crazy, that is up to you. All right, here's game A. So no one needs to talk. I will then randomly call on people to try to make predictions of what goes in the boxes. So, like if I put a 2 here, well, that's wrong. Still wrong. Don't freak out. I want to be able to write on it. So what I noticed was if I write using the ink layer of the TV, it does not come through on the video. So for the fact that we have classmates that are sick and out for various reasons, I need to be able to write in here. For this first one, I don't want to give you quite as long. Now, without telling me the rule, I'm going to come back and write over here. Does anybody have predictions for what goes, like what should I put here? Simon? Don't. Negative 34?
Negative 32, sorry.
Negative 32. Ooh. Now again, we're not giving away the rule yet. Anybody able to tell me what goes here? Or you can choose what X you use. Alex, I saw your hand next.
Negative 1/2.
Okay, what's the Y?
Negative 1/2.
Oh, it is negative 1/2? Ooh. There. Negative 20. Oh. If you have yet to recognize this pattern, if you think you know the pattern, what number goes in this box? Just shout it out. 2.5. What number goes in this box?
25.
Who can describe us the pattern in words? Katie Ann?
Like words or symbols?
Either. I mean, just, yeah, tell us what you figured out.
3x plus 1 equals y.
Y is a result of tripling the x and adding 1. So, if we triple 10, we get 30, add 1, 31. This is where it's a little funky. Triple negative 3 is negative 9. But then add 1, negative 8. Not negative 10, right? That's where people get goofed up. Simon?
So the way it works is you can't have 3x because then that's x multiplied by 3. You have to have x plus x plus x.
You can actually have 3x. So we can just say 3 times x
Well, how does it
plus 1, or you can do x plus x plus x plus 1. You can do that too.
I know the way it's more convenient of writing it, but 3 times x with the negative 0.5. How would that work?
Oh.
It's negative 0.5 times negative.
So do me a favor. Ask the question using a tone of voice that says, this can work. I'm actually seeking an answer. How you're asking it right now, it sounds like you're an idiot, this won't work, we need to do it, there's only one way that this, you know what I mean? Do you hear the difference between like, so what you should be saying is like, hey, I don't understand how that works, how is it that we can use a 3? So this is saying triple, right? 3 times something is triple, we have 3 of them, so we know 3 times x means the same thing as x plus x plus x. I think where your confusion is coming in is when we do that with a negative, like even let's say negative 3. Remember, this is not minus, this is like directional, right? So if I stand here and I say positive, what even way would be positive? That way probably?
Yeah.
I don't know, positive, negative. I like vertical better. But, so if I'm standing here and I say go negative 3, negative 3, negative 3.
My confusion is coming from negative 0.5 or negative 1/2.
Okay. So I go, start at 0, negative half, negative half, negative half. But then when I add 1, and go back up. So you are doing triple of the input value. So let's say we're talking debt. You take on a debt of 3, a debt of 3, a debt of 3. Or is there something in the cafeteria that costs 50 cents?
Yeah.
So you go buy 3 Scooby snacks. Down 50 cents, down 50 cents, down 50 cents.
It's a fraction.
You know,
Fraction, when you multiply fractions, when you substitute x for a fraction, that fraction instead of just multiplying the fraction?
Well, it's the same.
Well, wouldn't multiplying the fraction give you 0.25 and then multiply by 0.5 again? And then
No.
We're doing triple the fractional value.
It's
So,
simple.
shh, stop. Go to school and become a teacher. Okay? I think you need to go to school and become a teacher. If I write it as a fraction, 3 is a fraction. Can be. It's just 3 over 1. Then we go through the top, through the bottom, and this becomes negative 3 halves. But then when I add 1 to it, we have to go back up by 1, which leaves us at negative half.
I just didn't get how the negative 1/2 would go to negative 3 over half.
Are you good now?
Yeah.
Okay. Any other questions, confusions here?
Silent game. B. Oh, that's not what you want. New rule. New iteration. Yes. Give me just a second. I will make it go in there. So there's all 3 that we care to see at the same time. Guys, I'm not looking for hands or anything right now. You're just taking time to think and write it down on your paper. And if you haven't written it down on your paper yet, there's absolutely no reason for your hand to be up. It doesn't really matter that much. I just want you writing things down to engage. But I appreciate you asking. 3-9. Mrs. Pettigrew's the best baker. She is. It's, no. Although I have hours to submit, but they won't do anything for me. They're just going to keep the. It doesn't bump me, so I need to do that at some point. That's what I figured you were doing. See ya.
How is she the best baker?
Gosh, she bakes amazing food. She's just really talented. These are tough, so take a moment.
Is that her?
My positive stayed positive. My negative stayed negative up until down at the bottom. So, because I've been talking the whole time. Ooh, I think I know it. Always think about there's potentially a multiplication or division, right? 'Cause they're the same thing, and potentially a addition or subtraction. Both can happen. So always tell your brain, like, what if I do this and then that? Write it down. Write it down. So that people who haven't seen it can start to see it. Predicted value here, Henry.
I predict that the value will be 2.
Wonderful. Predicted value here, Liam.
106.
Predicted value here, Alex.
7.
Ooh.
Oh, wait, no. Yeah.
Ah, it's that simple math. Oh, there it is. Barry, you did one last time, right? I'm trying to get new people. Charlie?
That is 6.5.
6.5. Ooh. Alex?
I'm gonna do 40.
Okay.
86.
The 86. Simon or ooh, Ellie, let's do one more. What of these do you want? What is our rule happening here, Simon?
2, so the y equals, wait, yeah, so 2 times x plus 6.
I got that. I just looked it.
That is our rule. So what we should recognize is we are doubling the quantity but then going up. And one of the big indicators there is that the negative they started with, negative 12, became negative 18. The positive that we started with, 10, became 26. But then I had a negative become positive, which means there's not just a multiplication going on. Right? Because if there was just a multiplication, that negative would stay negative. Here's a new one. Yeah, I can zoom. Give me just a second. Because you only really need to see a few of them. Undo. You really only need to see these. Who immediately thought times negative 3? And then who figured out that won't work? Good. I skipped the 1 and the 3, but I went straight to negative. That's why I thought negative 3. Right? Up there, it looks like times 3, but that doesn't work. All right, I'll shut up. You just think. This one's tougher. I think I got it. Guys, genuinely, a lot of times I don't look at the teacher keys because I enjoy doing this too. So, like, I am actually doing this with you. I don't know what the rules are until we pull them up. Like, I knew what the lesson was. I had looked at these, but I hadn't figured out the rules yet. Engage with this. If you haven't figured out the first two, take time, try to figure out this one. Are the values getting bigger or smaller? Bigger, right? Now I'm not talking positive, negative, but they just get larger, right? So I know I'm probably multiplying by something. And then depending on what I multiply by, I would either need to add or subtract. Now, those two at the bottom, the value gets bigger, but it doesn't stay negative. So it's not like it just doubles or just triples. The sign also flips. So if you notice that the sign flips there, what does that tell you about what you might multiply by? Ooh, a negative. So let's pop back here and take some predictions. Patrick. You can tell me whatever input you want. 8? Oh, the negative 8? What? Oh, you mean this is 8? Okay. Simon?
Negative 17.
Nice. Henry?
Okay, the answer there would be 21.
We've officially made it past 21. I was waiting for years for that stupid meme to die, and it finally has. There, prediction here. 4. Liam? I'm so glad you don't know. It was seriously just a really dumb meme where it was just a kid being asked what something plus something. Yeah. So for the longest time, I could not say the number 21 in math class without the entire 21. And we're beyond it now, which I'm so happy about. What's our rule here? Alex. Yeah, what's this? Or that. Negative 2x plus 5. So when you recognize, we're going to play at least one more of these. When you recognize that the sign flips, you know you're probably multiplying by a negative. Now, not always for sure, but that's a really good indicator of there's a negative multiplication happening here. Try this. Ooh. Yep. Give me me just a second. I'll zoom in. Much easier if you just think instead of talk. So this is all we really need to look at.
There's a 4.
So your immediate gut reaction might be times 5, and then your heart gets broken when you look at the 6.
Oh, right.
So you always have to test, will it actually work? If you are sitting there not thinking, shame on you. Turn your brain on. When you think you know it, check it with the 1/3. That's how you can check your math. See that moment. Don't rob anybody else of that feeling, right? It's a fun feeling where you're like, got it. 20 turns into 420. Lordy. It's a big output. Do we have some predictions that think they know it? Yeah, if we come back over here. Henry.
The answer to that is 10,100.
That? Wait, we'll take more. There?
Wait. It'd be negative 18. No, it'd be 18.
It's not. I'll type it in so you believe me, but it's not. Alina?
Oh wait, I don't know why I did that.
Oh, you can do that. What is this?
It'd be 90. I don't know why I said 18.
It's not 30 either, Bear. You're done with your guess. Ooh, crap.
What?
No, that's okay. Well, put an asterisk on this. We'll talk about that in a moment. That could be 30 or 42. There are 2 potential answers. I will tell you why, and this comes down to a your calculator is stupid thing. No, trust me, seriously. So this one, I also predict their answer is not going to be what I feel like it should be, but we'll talk about why in a second. Simon, what do you think this should be? Because I actually think it should be 15, but I know they're not going to say it is.
Yeah, I think it's negative 12.
Negative 12?
Wait. Just wait.
Yeah.
I think they're going to say it's negative 4.
It's gonna be negative 9. Negative 9.
No?
No, I thought it was negative 12. I'm
Pretty
pretty
sure it's 6. Yeah.
Oh, I don't know why I said 9.
Oh.
And I disagree with that.
Oh, yeah, that's what I meant. Sorry.
I disagree with that.
Why?
Because I will explain to you in a moment, guys. Just hang on. I want to make you hungry. What is this?
We are getting hungry and hangry.
What should my last number be? 1, 2,
I
3.
don't like your math. It's hard.
It'd be 5. No, it'd be 0.
No.
No.
Wait, what?
It's 255.
What's 50 times? Oh, yeah. Why did you say our last number?
Because I did it wrong.
I said 0.
Wait a minute. Did anyone see that?
Yeah, I did.
Yeah, those are.
That's what's like, oh, wait, oh, like, this
Oh,
is way
I didn't see that.
It's like, wow.
So they went ahead and told us x is squared potentially, right? I could put a 0 here and make that not do anything. But does anyone have a prediction for the rule?
1.
Logan?
I just want to say we got some imaginary numbers here.
Not imagine. Well, okay. It depends on forward, backwards. Let's not talk about that's too deep. I know what you're talking about radical negatives, but that's too deep right now.
Has anyone?
Elena?
Calvin?
Yeah.
x squared plus 1x, and so that would be 0.
Yeah.
The rule here
What was the other one?
is x squared plus x.
I just put
Now, here's why I say I disagree with their rule. Or not their rule, but so your calculator, please put pencils down. We're actually going to just take a moment to talk about this because this will come back around many times in your math career. Your calculator is coded in a very specific order of operations and how it does things. If we say that our rule here is x squared plus x, then yeah, 9 squared, 81 plus 9 makes 90. Right? Do you know where I'm going with this, Henry? Or if it's a different question, I want to finish this first.
I beg to differ with this rule. I believe the answer is x times, in parentheses, x plus 1.
That is the same exact thing. So you're right. That's the same exact thing as this because, so what Henry just said is x parentheses x plus 1. If we distribute that, x squared x. But Henry's just saying, well, I could also just take, if my x is 9, and multiply it by 10. Right? If my x is 100, multiply by 101. It's just a different way to look at the rule. Henry, are you with me? That it is the same. That's also correct. It's just a different way to look at that rule. Here's where your calculator's kind of dumb. What happens when I multiply a negative number times a negative number? It's a positive. Now, and I'm going to teach this now, but this actually works right here, but I want to caution you before you start using calculators to do stuff like this. So I'm not saying CPM's wrong. I'm just saying I have an issue with how they presented it because we use negatives. So negative 6 times negative 6 is what?
negative 36.
No, it's not.
Positive
Negative
36.
I don't know why.
But your calculator, if you type in negative 6 squared, and you literally type it negative 6 squared, this will
Negative
come
36.
out in your calculator an answer of this, which is wrong. But it's not wrong, right? Because your calculator can't be wrong. Here's what happened. I got a few eyes not on me, and I'm worried about those eyes not on me. Your calculator follows the order of operations blindly, right? It doesn't think. It just follows the order of operations.
Oh, I get it.
Powers come before signs in the order of operations. So if you want your calculator to do this correctly, you have to. No, you don't know what I'm going to say. I appreciate you trying. Hey, Logan, can you let the teacher teach for a moment? Hey, Logan, you can either let me finish my statement and stay in this classroom, or if you need to talk, you can leave. Because I'm trying to get your classmates through with class with time to work on their test. I know you probably know what I'm going to say, but I need to explain it in the way I need to explain it so everybody can understand it. Is that okay with you? How we fix this in the calculator is we group the negative with the 6. How do you group things? Parentheses.
Make it a parenthesis.
So this, do not put the square in the parentheses. You have to do that. Then it will come out to be the positive 36 that it should be. So where this is dangerous is if you're just plugging things into the calculator, you might think you're wrong just because you typed it wrong, and their rule down here doesn't have parentheses in it, right? That's where I would say our rule is parentheses x squared, which only matters when you type it in the calculator or have a computer do it for you, but then it's plus x. So be careful when working with positives and negatives. Patrick. It is right, but the problem is how you're typing it in. Because when it processes, when you type in this, it does 6 squared opposite of it. that is not the same in your calculator as typing in this. Because this says the quantity of -6 times itself. These are two different things according to your calculator. That's my soapbox. Here's the problem with the calculator. Now it's right. It's just following the order of operations exactly.
Pardon the interruption, Nancy.
And we don't know
Margaret
this.
Malloy to the office. Margaret Malloy.
Sometimes because we know certain things, like appropriately written, we should have the parentheses here, right? Negatives should be put in parentheses, but we don't have to, as long as you know what you're doing.
Will it do
Dan?
on a test if we put -36, will we get it wrong?
If you got the answer for your calculator and it's the wrong answer, it's wrong. But if you so -6 squared is +36. Like this is +36. But this, if we're being technical, is 6 squared and then the opposite of it. So it's -36. So it depends on what the question asked you. Did the question have the -6 in parentheses? Or did it not, and therefore the square comes first and then the negative happens? Simon? I don't know. I haven't gone that deep into it. Probably, but I wouldn't go deep in trying to change really important features. I would just get yourself to type the parentheses. Really, my advice is just type the parentheses. That's how you fix this. Is you type the parentheses.
Well, or you could just write it's the same as -6
Times -6.
times
Yeah.
negative.
You could also do that.
The times
Or you could just not type in the negative, because we're all really smart and we know a negative squared makes a positive. So since you know a negative squared makes a positive, just don't type in the negative. Right? That's the other way that you fix it, is don't let your calculator do it wrong. On a test, always think in your head, does this make sense? Right? As you're using your calculator, as you're using your calculator, you want to always ask yourself, does this make sense? Man, the amount of time that we have left isn't really productive for people working on their tests. If you are not able to spend some time on your test during extensions or AO, I promise I will budget some class time this week before we get towards mastery deadline, but today it's not going to happen because we're running out of time. So look at your resource page on the back of it.
I thought this week was just the grade cutoff.
Yeah, you are correct.
Okay, good.
Yeah, I just mean as we get toward, I know some people are already thinking about this Friday, and that's kind of far away. I just don't want people freaking out.
So is 2025.
One interesting thing about trees. How does a tree grow?
It's 95% carbon dioxide.
Okay, you guys are way more particular than what I'm still getting used to teaching a group like you guys. Where does a tree grow from? The bottom or the top? The top. If you didn't know this, which I didn't know this actually for a long time, trees grow from the top, which is why, if you're in love with somebody, you go carve your name into a tree, which is mean. Don't carve into trees. I disagree with that. But that carving will stay there. Actually, because it grows from the top. It keeps shooting new branches out, and it keeps pushing nutrients up. So, John is in a redwood forest, and if you've never seen the redwoods, they're the biggest trees. They're hundreds of feet tall, grow super old. So, John has a baby redwood, right? And even a baby redwood, 3 years old, is 17 feet tall. Yeah, that's a baby tree. But when we look at this, do we see a consistent change happening or a non-consistent change? Consistent, right? What would be our consistent change that we see here?
Adding 4 feet.
Add 4 to every year. Now, here's the issue. When we go to formalize this in a y equals format,
It's impossible.
when we know it grows 4 every year, that's nice, but where do we start? How do we figure out where we start in a function or in a relationship like x, y? Got the same hands I've had. Anybody new want to engage with me?
My head. Someone took my hand
Logan? Yeah, how do we figure out, like, so when we were writing those, the rules back up for the silent board games, we had, like, something going on to the X and everything, but then we had a start, and here our start was 0, right? But if, like, there was no X's, right? Well, we're really asking if there was no X's, or if the tree hasn't grown at all, how tall is it? So take a moment on your resource page, write down what you think in year 0, when he bought the tree, when he planted the tree. He didn't plant a seed, right? He bought a tree and planted a tree. Then we want to be able to answer, how tall was it 2 years after it was planted? Or 7 years after it was planted? I mean, if you want to put it on the graph, we can, but we're going to run out of time really fast.
Should we see what it was in year 0?
Yep.
5. I think I know what the
The moment it was planted. It went in the ground, that started the clock. Why did I keep losing these? Logan, how could we get back to the beginning?
the function is 4n plus 5.
Ooh, now we got to figure out how do we find that 5, because I never want just answers. We want to know how we got there. How'd you get there?
What's 17 minus? Well, all I did was just take the first one, 3 multiplied by 4.
Okay.
I was just going through all the multiplications and I noticed it was like 5. And I mostly just noticed that a lot of these are close to being multiples of 4. Not quite.
They're both really close multiples of 4. So we keep growing by plus 4, right? I would write the plus so you know we're not doing multiplication. And plus 4. So wait, if I do this, minus 4, ooh, or plus negative, like that. I can get year 2, I can get year 1, and I can get year 0, which is, if I take away another 4, 5 feet tall. So the big thing that we want you to understand before you walk out of here today, this consistent addition, this is what people get confused about. This addition of 4 is every time, right? Add 4 every year. So that tells us the height. We can say h here for height, right? The height will be 4 times the number of years. I'm going to put t so we don't use y, so t for time, right? Plus 5. This, like you're right, like couple last things before we get out of here, is in what we call, actually I write it in blue, write it nice and big, and blue's easier to see, I feel like. The y equals mx
MC squared.
plus b form. Notice how what you're saying is not helpful to us finishing class. This is called slope intercept form. And why it's called slope intercept form, I got a lot of pencils not writing, and I feel like later you're going to be like, wait, slope intercept? When did we learn that? This is our slope value. And this is our intercept. And because we're out of time to do the graph, we'll pick that back up later, but this tells you everything you need to know to make a graph for this relationship. This tells us our start point, and this tells us how we change as we move. That is all that I have for you today, so please keep track of this resource page. We're not totally done with it yet. We might come back to it. And we will work on your test at some other point.
Light is not very good, but okay.
This until extensions. Okay.
Good afternoon, Ian. Can I please have Layla? Yes,
Do
please.
what?
I have ice, 6, and 6.
So I just have about 5 seats in the backyard. They're all about very tall. But for me, that's year 0. I don't know exactly how old they are. I didn't know they were continuing
And
to
Quinn Wilson stopped by the office.
So now my clock is starting. Next summer, I go out there and they're like this tall. that to me is my first change. Right? So I agree with you. Plants, I normally think of seeds, but like, you know, a lot of times we start with an initial value. Logan?
Hold on a second. Logan!
Where's your test? Did you put it in the bin? Or, okay, I wanted to make sure that you didn't have it. Okay, sweet. Oh, yeah, you need your homework. Because I didn't want you to have it yet. Get one of these as you head to language arts.